Good morning, everyone. This session is about how chess data can be a driver of science, how chess, what the relationship between chess and science, and vice versa, also what science can do for chess, and some examples of chess data-based science will be in this session. So the speakers in this session, those scientists. So that makes this session a bit different from the other sessions in this conference. But we used to have such sessions every year in the London Chess Conference at some point. At some point it was workshops where it were heavy on methodology, on exchanges between scientists. Today will be a bit more accessible in that respect. Still expect some heavy stuff coming your way, not too difficult. First speaker, I'm very pleased, Barry Hymer is, we were honored to have him before, and the feedback at that time was brilliant. And he used to be a professor of education, I think Lancaster, is that right?
In Lancaster, yeah.
And he was more into, not into empirical research, but into philosophy of education. And I think Barry was an active secondary school teacher before. So he went to bring up the next generation of teachers and to work with schools also as a consultant from practice, not just from academic points of view. But now recently, I think, Barry, you stopped teaching at university, right? Mm-hmm. And now you are probably focusing on other projects. You're not retired. And one of these projects is a fantastic new book, Chess Improvement. Barry probably will touch upon this later on in your talk, so I shouldn't say too much. It's just been recently published together. Barry wrote this together with Peter Wells, chess grandmaster from England. And Barry is also now the science consultant of Chessable. And we are very pleased. Chessable is a sponsor in this conference, and Chessable has suggested this lecture and brought us together for this. So thank you also to Chessable for making this connection. And Barry, please, the floor is yours.
Thank you. Thank you very much, Stefan, and thank you very much for the invitation to speak at this event. Yeah, just one or two little clarifications. My background is actually as an experimental psychologist, but I did, as you correctly say, move into the philosophy of psychology and the philosophy of learning much more in the latter parts to my career. I am still emeritus professor of psychology and education at the University of Cumbria. And just for anyone who may not be too familiar with the arcane academic lingo, emeritus says nothing about distinction, and it says everything about age. I'm now an aged professor of psychology in education. I left my formal role in order to spend more time doing research and writing. And perhaps that says something about the state of academia, at least in the United Kingdom at the moment. But no, I love the role, but I have been filling my semi-retirement with my childhood passion for chess. And the fruits of that, as Stefan correctly pointed out, came out just a month or so ago in the form of the book that I co-wrote with my good friend and grandmaster, Peter Wells. I'm not going to say too much about that book. My focus in my session this morning is very much on the work that we're doing in Chessable on the science of learning. Delighted with the title of the workshop, partly because, as I think everyone here knows, because I know that there's a huge amount of expertise on the other side of my screen, that science does not necessarily provide single, easy, definitive answers. And as a social scientist in particular, I'm aware of the gap between social science and social policy. In fact, in the age of COVID, I think we're all aware of the gap between hard science and social policy as well. But for what it's worth, I'd like to say just a few words around the relationship between chess and the science of learning. I'd like to start with a quotation from our recent book, and it's in the elegant words of my co-author, who noted this, that when considering deliberate practice in relation to chess, we're not exactly applying the theory so much as revisiting the terrain on which much of it is built. And what we mean by that is that we are very fortunate in the chess world in that so much of what we know about learning theory has come about because the studies were conducted in the field of chess itself. Chess has been a wonderful proxy for a whole variety of areas of current understanding, current knowledge, including the vast field of deliberate practice, which of course relates to the work of the late great Anders Ericsson, of which a little bit more very, very shortly. So what I'd like to map out initially is just a very brief thank you to a number of the researchers over the past century plus who have included chess in at least an element, and in some cases a very substantial element of the research they've done in such broad fields as expertise, intelligence. The first name on the list, of course, is the founding father of the intelligence testing movement, who with his student Theodore Simon set out to create measures of intellectual ability for very positive reasons, to try and help us predict which children were going to need some kind of educational remedial support in their education and which children might not. Unfortunately, in the 20th century, as we know, the intelligence testing movement took a slightly darker turn and began to be applied for sifting and narrowing processes, particularly sadly in America and particularly ironically at Stanford University, which many years later became the seat of one of my psychologist heroes, Carol Dweck. But what we see in that list is individuals who have used chess as part of their studies to try and find things out about how we learn best, and how we can acquire ultimately high levels of expertise. And of course, one on that list will be following this presentation. I look forward to hearing Fernand's current work. Of course, the big beasts on that list in the chess world are people like Jason Simon and indeed the great Dutch psychologist Adriaan de Groot, a lot of whose work was then picked up subsequently by people like Anders Ericsson and developed and taken further. But what I'd like to do is to kind of acknowledge our debt to those individuals and just relate that to Chessable's own learning platform. And many of those individuals, plus many others, were used in the foundational work that people like David Cremeli and others have used to build the platform. And if anyone would like to see a brief but very cogent summary of some of that work, it's up on the Chessable platform and is free to view. But it looks at things like spaced repetition, which of course becomes central to the move trainer technology of Chessable. Scheduling, why scheduling, so that we are focused initially on things that we haven't learned particularly well and can master those and hardwire those. Dopamine hits, how we can have our learning supported through chemical changes and the recognition of learning. One of the key chapters in our book was on feedback. We related specifically to challenge, because challenge and feedback do seem to be the warp and weft of high-level engagement in the field of learning, and the enactment effect, just doing things, and the learning that happens almost as a secondary gift as part of that, and then work, of course, building on the great Russian psychologist Lev Vygotsky, making sure that the level of challenge is just within our ambit, rather than too far, or indeed already part of our learning repertoire, in which case no new learning is likely to be taking place. So that's some of the background to the creation of the learning platform at Chessable. But much more recently, we've begun an audit of not just this research, but of potential new research which might need to be built in and developed as part of the Chessable learning experience. I can say, I think with total sincerity, that until my very recent engagement with Chessable, I've never actually worked within an organization which can be seen to have a growth mindset in Carol Dweck terms. But I think I found one in Chessable. Right from the outset, I have been urged to critique elements of the Chessable experience. And as part of our audit, we're using the De Bono plus minus interesting model to try and identify the features which are currently working well and which we want to either strengthen or at least maintain in its current form, but also pick out on some of those features which might be a little bit contradictory to our message, things which are not particularly working well. We have already received feedback from many of our users, for instance, that the review function is a kind of passive-aggressive bully sitting in the background of their learning experience. You know, it's there for a reason, and it does work, but it can be quite oppressive in some experience when you see, because you happen to have a 7-day holiday, that your review numbers are building up close to 5,000, and there doesn't seem enough time left in your life to begin to address those. So we need to perhaps do some fine tuning about how that function is used. And then in that third column, interesting factors. We're not necessarily looking at positives or negatives, but just things which are going to be interesting for us to consider. And one I've got in my provisional audit at the moment is how we reconcile in Chessable the extrinsic motivators, which are very strong and in many ways very effective and very successful. The points and the rubies that we can exchange for added features, and the points and merits that we get for maintaining a streak of engagement in the program, all of which are very powerful extrinsic motivators, and many of our members do love and use very well. But there can be a tension between those, as we point out in our chapter on motivation in our book, between the extrinsic drivers and the intrinsic drivers. And what we know from a lot of research is that extrinsic drivers can have a negative impact on intrinsic motivation. We start doing things for our rubies rather than because we are enjoying the process of learning and acquiring new skills. So that's going to be a factor which we're going to need, I think, to handle quite adroitly. You know, how do we make sure that we call on good extrinsic drivers when appropriate, but without allowing those to impact negatively on our intrinsic love and our intrinsic passion for chess? So watch this space. It's something that we're engaged with at the moment, and we will be looking forward to how any potential changes are received by our members and taken forward from that position. I will just say that I'm going to kind of get through at some speed my presentation in order to build in some time at the end within my half hour for any questions, and I will welcome anyone who'd like to come in with a thought and observation. Please just store them up or make brief notes for yourself or add them to the chat column, which I can address in a few minutes' time. Because my remaining time, I'd like to just talk about where we're going at the moment and the potential impact that's going to have on the Chessable platform in the future. We've got some very interesting creative researchers at the University of Sydney, and one of whom will be shortly joining the University of Harvard, that we're very much enjoying working with. There are two elements to the research program that Chessable is a partner to. The first element is taking the form of a questionnaire, which our colleagues are developing, which address 4 significant areas around our members' engagements with chess learning. The whole area of self-regulation. How do we take ownership for ourselves of our learning approaches and apply those to solid learning strategies, which are going to help rather than hinder development in chess. We've known for a long, long time, and in fact we reference it in our book, that many individuals spend a huge amount of time studying and playing chess without making significant gains. And the holy grail of chess study, of course, is seen that recognized in the algorithms of chess ratings. What we do know is that some individuals use better learning strategies than others and therefore make faster consequent progress. And in fact, that has been the foundation of the whole Chessable learning platform. How do we create a set of tools that are going to drive learning, and particularly at my age, with my aged neurons, support the synapsing of my neurons in order to retain material, rather than just acquire it and think, yeah, I've got this opening, and discover the next day that it's all gone. So how do we kind of make sure that those learning strategies are maintained and built in? Supporting agency, so that the learner believes that it's not up to Chessable or up to their coach or up to their parents' chess genes for maintaining that progress over time. So how do we make sure that self-efficacy is built in? And we've developed with our partners at the University of Sydney a range of items which tap into that. And finally, this whole notion of intrinsic value, some of the elements that I was mentioning briefly earlier. So it's not just because I'm garnering millions of points on the Chessable platform, but it's because I'm deriving pleasure and engagement through the process of learning itself, rather than the end points of the rubies or whatever the motivator and driver might be. And I'd like to just share with you a few examples of how we've operationalized these four areas. From the area of self-regulation, we're asking our users, and we will be inviting many hundreds of Chessable members to engage in this very brief questionnaire. How do you approach if you encounter a position or a puzzle and you don't understand the correct move? Do you explore it, or do you move on to the next puzzle? And quite clearly here, exploration is likely to be a more productive learning approach than simply moving on to the next one and leaving understanding behind. And it's one of the reasons why we decided ultimately, in beseeching our users to be honest in their responses, we weren't able to promise them that there are no correct or incorrect answers, which is a fairly standard thing to do at the beginning of rubrics for questionnaires, because there are some more correct and perhaps less correct responses over time, though there's no judgment taking place. And similarly over here, we ask the question, well, you can read that for yourselves. And here again from the learning strategy section, what we know around master practice is that there's an awful lot of prophylactic thinking happening. Yeah, okay, this is a great plan that I've got, but am I anticipating what the response could be over here? And we just like to tap into the extent to which our members are already using that strategy. And here's just a brief little item from the self-efficacy set. I'm confident I'll be able to effectively learn the material I'm studying. We are expecting a wide range of responses if they're honestly delivered over there, because we've had informal feedback already from many users that many people come with a low sense of self-efficacy, perhaps based on being stuck in their rating and chess improvement over a long period of time. And we just like to align that with other measures that they give us. So these are just a few examples of the first stage of the project at the University of Sydney. A second stage is a slightly more ambitious project, and it's fascinating the ideas our partners have already got in relation to this. The Holy Grail, as Fernand will tell you around chess, is this notion of transfer, either near or far, and how elusive it is to make these transfer leaps between knowledge gained in one specific situation and transferring that to another. And there's some really interesting ideas that they're developing with us around transferable knowledge and understanding of core concepts, which will include things like tactical and strategical motifs, and then even more ambitiously, how we use our capacity to think about thinking and our capacity to be aware of our tools for learning. And just one or two little indications of how this may be used from a very simple level. There'll be some introduction to some basic tactical motifs, for instance, a fork. And then there's going to be opportunities for our members to show us to what extent they get the deep understanding of a fork, or are they confused by the superficial context of a position. So one little example could be to unpick a fork in one diagram with a fork in another, but in one diagram the position is so similar to the key that the superficial features might outweigh the deeper element, which might be the fork itself. And in that context, we want to see to what extent they can get beneath the clutter, the fuzz, which might be distracting them from the deeper understanding. More ambitiously, perhaps, in learning openings, we're keen to see how in Chessable we can use learning acquired in one situation, for instance, learning the King's Indian attack, and then be able to transfer that knowledge in analogous positions. We're working with Grandmaster Alex Kolovich, one of our team members in this, and he's been very helpful in suggesting ways in which it's possible to get chess players to see that something learned in one opening, like the King's Indian attack, could have features which could be very, very similar, playing the black side in a King's Indian defense, and how particular approaches learned in the King's Indian attack might then transfer into those. So this is a work in progress, and some very exciting current positions, but we look forward to seeing how that develops over time. The second stage is not quite as advanced as the first stage, which is very close now to going out to members for their learning strategy and self-regulation responses. And then the third study, which is in the offing, is conducted at the University of California. And given the history of California and the well-being movement, it's perhaps no accident that it's located there. But we've got a wonderful postdoctoral researcher at the University of California who's keen to unpick with us the relationship between chess and its potential role in supporting mental health in these ages of COVID, excessive screen time usage, surveillance, etc. This again is at an early stage, but we're working closely with him and look forward to be sharing some of our ongoing activities there very soon. At the moment, we're at the stage of identifying possible scales for application amongst our members. And again, of course, this will be a voluntary invitation to take part. We're very aware that this might therefore lead to a slightly skewed response, but we're looking at ways of adjusting for that as well. These are some of the scales we're going to be embracing, including some very old and well-used ones like the direct mindset scale and Rotter's locus of control scale. My final little comment before I open up the conversation to any of you in chat or indeed verbally is to let you know that we are very open to new ideas and new research partners. We have some capacity, of course it's limited, but nonetheless we do have existing capacity, and we would very, very much welcome anyone who has an idea in the field of chess learning, which has potential applications in terms of our technology, to get in touch with us, and we will see how and to what extent we can work with you in making that research a reality. So thank you for your time so far. I will stop, and I'll stop my screen share at this moment, and I'll invite anyone to come in.
Questions you can ask through the chat, but as we are not so many, after a first question I'm taking from the chat, you can also unmute your microphone to ask a question. I saw someone asking about chess blindness. Is that something that you have been tackling together with Chessable, Barry? Is that
Not me myself. I don't know if David is with us or any of our other Chessable colleagues have been exploring that specifically. If they wish to come in at this moment, please do unmute and say so. Could I just ask, in relation to chess blindness, what the thinking behind the question is? Is this coming in from a particular approach?
Yeah, hi, it's Michael Sutton with
Thank you, Michael.
Chess Institute of Canada. Yeah, I was writing a column on it, but I just find it a fascinating, subject, why even top players cognitively overlook certain things, and it's almost like they can never see it. And I find that fascinating, why that happens. And
I mean, there's potential for a very interesting study there. I mean, we can all think of those moments, Petrosian classically overlooking the fact that his queen was on pre at a top level game, and how that can come about with somebody of his strength. There is something we do already know about which moves are more difficult to predict. Queen and bishop diagonal retreats, of course, are well known to be some of those which are most easily missed, and that's something which is used a great deal by study composers and problemists, because there's something about the way our brain is configured that makes those particular moves tough to see. But in terms of a specific study, fascinating area, and if you have the time and motivation, let's stay in touch and let's see if something might come of that. Thanks, Michael.
Will do. Thank you. Thank you.
Before we forget, will your presentation be available? Will you share the presentation? Possibly through the Chessable website and through the conference website, both? Can we do like this?
Yeah, I've sent the presentation to Stefan, so he has access to that and can send that to anyone, but you can receive that from me as well if for any reason that route doesn't work for you.
I've shared a link in the chat, guys. You can click on it if you need it.
Thanks, David. I did notice a question earlier, someone just wanting this concept of metacognition to be unpacked a little bit, and thank you for that. I, did move very, very rapidly through that. Metacognition is simply the capacity to think about our thinking. It's got a noticing element to it, a self-regulation element, and an acting element on it. But it's what we know, experts in a huge variety of fields. We could probably go so far as to say all fields of human achievement are likely to involve a strong metacognitive element at the higher levels. In our research for our book, we interviewed most of the leading English grandmasters over the last 20 years, all rated at or about 2700. And what was a significant feature was how all of them revealed at different points exceptional levels of capacity to think about their own thinking, recognize areas of weakness, begin to address those areas of weakness. That element of noticing is one of the cornerstones of metacognition. And we just needed to kind of read through Matthew Sadler's transcripts, for instance, to see how searingly self-critically he applied his awesome metacognitive powers as a way of prosecuting his own development. Matthew was interesting in that we call him a leverager. He's somebody who, which is a term that Howard Gardner gave us, uses his strengths in order to score points on the chessboard. A lot of our interviewees were kind of quite universal in their approach and tried to kind of spread their energies across all fields of the game. But Matthew acquired huge success as a leverager, particularly making sure that he moved into positions of high complexity, Alekhine-like complexity, where he reveled and applied his really fearsome levels of concentration. So in order to be aware of where his strengths and weaknesses are, he needs to be able to think about his thinking. And we actually use a quotation from Bronstein in our chapter on metacognition in our book, in which Bronstein made the remarkable observation that the essence of chess is thinking about what chess is, which is so meta as to be almost unreal. But what he's driving at there is our need constantly to be thinking about our thinking as players, not just at a tactical strategic level, but about us as learners. How are we addressing the entire concept of learning about chess and chess improvement?
What do chess coaches need to know about metacognition? How can they use this when they are working with their students, maybe also in one-on-one situations. How can do you address this very much in the book, and what do you suggest?
Yeah, we do try to. We try and make the link over here for chess coaches and metacognition to notions of challenge and feedback, and to steer away from simply giving advice or instructions, in giving as much of the load over to the learner. So a question from a coach along the lines of, what do you see as the strengths and weaknesses in your position here, is a question that's loaded with metacognitive potential, because it forces the pupil to, if you like, get above their game and to look on it as if a disinterested and interested observer would be looking at it. And in that case, they're having to use a strong capacity to think about their thinking in identifying strengths and weaknesses. So we give a set of questions along those lines, which are very easy for coaches to apply and are rich in metacognitive potential. Anything which gets the learner doing the work is likely to be supporting metacognitive development. But we do also talk in a later chapter on how coaches can be using small group work in order to really push for metacognitive learning and indeed for cooperative learning in that context as well. It's crucial, I think, that coaches support metacognition from a very early stage.
Can you show that metacognitive skills, or specifically a growth mindset, correlates with the development of players, the achievement?
Yeah, we do this kind of in reverse. When you look at the research evidence around metacognition, a lot of that is done on what expert learners do. And we unpick 5 broad areas in the book of what expert learners in the field of chess specifically do compared to what, well, I won't include you, Stefan, as a titled player, but certainly myself, what I would do. And one of the first observations we make is that experts are experts in metacognition. They use metacognitive processes more, and they use them better than somebody playing at my level at or around about 2000 ELO. And we go on to develop that, how they make links, how they are on autopilot for a lot of the game, because they're able to call upon a vast database of acquired knowledge, pattern recognition, etc., which we see when they're playing simultaneous exhibitions. The vast majority of their moves are very ordinary moves, and they're not needing to think very hard. But then they move into a position at a critical stage in the game where they do take more time. And this is where they need to draw upon new links and new processes, but only at the point at which their existing database requires it, because it's not there or not as strongly. And those of us who are less skilled in this kind of thing are perhaps needing to think harder and longer all the way along, and we're much more reactive in our responses rather than strategic in our responses. So yes, we unpack 5 broad areas, and we're able then to reverse engineer. So if this is what our experts are doing at the level of metacognition, how then does this look for those of us working, much lower down the chess food chain? And then how do we build up and scaffold the learning to get closer to that experts? The obvious point to make over here is experts were not born experts. They go through exactly the same processes as the rest of us have to do, but they've been there, and they've now reached a very different stage of achievement.
2 questions from the chat related to the transferability of these skills. Do you see strong players able to transfer what they develop in this type of skills to other areas of life or to life in general?
I think I need to be really modest in this domain. If they do, I don't think that the research evidence is in yet, and Fernand could probably address that question with more authority than me. But what we know about transfer is it's very elusive. We do talk a little bit in the book around the value of chess players acquiring skills beyond the actual game, because their life as performance artists is going to be relatively short, but many people are going to spend a lifetime a career in chess in some form or another. So the kind of skills of mitigated speech, of diplomatic speech, of interpersonal engagement, of being able to communicate really well, these are skills which are not necessarily created through the process of playing chess itself. But there is a role for them. We know, for instance, and we point out that great chess players do not necessarily make great chess administrators. There are obvious exceptions to this. You know, Max Oever, for one, was magnificent as a chess player and as FIDE president, but he's relatively rare. So we need to be modest about the fact that chess itself leads to this, even to the extent of relatively near skills like maths ability. There is some evidence that chess seems to have a positive impact, but it's quite equivocal evidence, and it's by no means hard and clear that we can make these direct claims. So what we're doing in our own work in Chessable is going to very much towards near transfer and building up from there. But we're a long way from making claims that, you know, chess ability is necessarily going to lead to development of enhanced skills in other areas. However educationally beneficial we know chess is, those are going to be much more at the dispositional level of persistence, engagement, creativity, risk-taking, and even there, we're still waiting for the studies to come in to prove that link.
Somebody who is not a presenter in this session, but in the session afterwards, David Smurden is with us. He's a grandmaster. He has just written a comment in the chat. David, do you want to come in shortly?
Sorry, yeah, I can come in. I'm also busy putting a 2-year-old to bed, so I'm sort of multitasking a little bit. But just to mention that with these sort of studies, and by the way, Barry, I find this talk very interesting, so thank you very much. But just to say that I like the idea of randomized control experiments for these sort of studies, and we don't have enough of them, but I think we're moving in that direction. And there were some researchers from Monash and Deakin University in Melbourne who did a study recently with some children in Bangladesh. And what was interesting for me is that it wasn't just one of those studies where they look at short-term effects, which is something sort of a bugbear of mine across a lot of fields, not just chess, when they do things like habit formation, getting people to go to the gym, but then they come back a year later and nobody's still going to the gym. But they actually measured this sort of long-term, and risk aversion was their main finding. They also had some findings to do with time consistency, patience, and creativity. I can't recall them off the top of my head, but I put the link in the chat so you can have a look for it yourself.
That's very helpful. Thank you very much, David. Thank you.
And another question that came through is maybe not just to you, Barry, but also to David Gramiley. It's about would Chessable make some learning data available for research, for academic researchers out there?
I'll give a brief response. Our data could be available. There are certain ethical issues that we need to adhere to in terms of how we access this data from our members and what the conditions are in which they give that data, and we need to honor that. But anything which is freely available at an ethical level, David, I'll invite you to unmute and come in here with your take on this.
I think you covered it quite well. I mean, even for internal research purposes, we need to have some sort of opt-in mechanism that people want to be part of this research. So even though we have a lot of learning data, we hold privacy at highest regards. It's your data, and you can share it with your coach. And then in the future, we have some sort of purpose for a study. We will ask you to see if we can use it for that as well.
Thank you.
Maybe the data scientists, I mean, the scientists who use the data, they are not data scientists, they can probably, they need a good idea of what kind of data you have before. I mean, it's more clear what is in game databases, or in rankings. We learn about this later on, but the kind of learning data that you're collecting, and you have a huge data sets, it could be something new, some roads not taken yet. Yeah.
I think our collaboration with Barry is a first step towards perhaps achieving this, right? So we'll take it a step at a time. First start with this survey type questionnaires that are kind of like lower hanging fruit, and then see what we can build on top of that.
Thank you, David. Thank you, Barry. Okay. Benjamin pointed out internal research, but you addressed this too. Yes, thank you very much. We move on here, but you will stay with us for discussion later on. Next speaker is Fernand Gobet. Fernand has been at our conference many times as a speaker, as a keynote speaker. And Fernand is a cognitive psychologist, originally from Switzerland, international master, but came onto the science track after a brief period in professional chess long ago. And he has recently moved from Liverpool University, where he's still affiliated, to London School of Economics, where he can devote much more time to research. And he's always full of ideas. And in spite of this, he's keeping his connections with chess and his interest in chess-related research. So it's wonderful, Fernand, to have you with us and to deliver us a talk that gives an overview of such research from psychology, I think. And you have a co-presenter with you who worked with you on this. That's Andrea Brancaccio from Italy, from the University of Padua, PhD student. Please, both of you have been made co-hosts. Fernand, Andrea, you can share your screen anytime. Up to you.
Okay, can you see my screen?
Yes.
Yep, okay. So today I'm going to talk about using chess databases to answer psychological questions. And this is work done with Andrea Brancaccio. This is an overview of my talk. First, I'm going to give a very brief summary of chess research. And then I'm going to focus on the analysis of databases. And first, I provide the method of our survey. I provide some overall statistics, and then I'll give a few examples of what I think are interesting results. Now, a lot of research has been done using databases about errors and gender differences. However, I'm not going to say anything about that, not because it's not important, but because the next talk is going to talk about errors, and the next session is going to talk about gender differences. So rather, I'm going to address 4 different questions. The first one is whether the Soviets cheated to beat Bobby Fischer. Then I talk about the question of seasonality of birth and expertise. I'll move on to risk across civilizations, and then I'll talk about aging and expertise. And of course, all these questions have been answered or partly answered using the analysis of databases. And at the end, I'll briefly discuss the strengths and weaknesses of using databases to study scientific questions, well, chess databases. So first, a few things about chess research. Well, it has been for many years a very active domain of research. And in fact, there is a huge number of papers published every year about chess. I would say most of the papers are in psychology and computer science, including artificial intelligence. However, there are quite a few papers in education, neuroscience, and mathematics. And what I'm going to talk today in my talk is mostly about psychology and computer science. Now, very roughly, it's possible to divide chess research into 2 main periods. The first one, I'm going to call it the classic period, and the second one is going to be the current period. So roughly the classic period goes from 1950 to 2000, and it has seen the similar contributions of researchers like Adrian Roth and Herbert Simon. And the main themes of this research were perception, memory, problem solving, typically how players decide what move to play in a game. And the main methods were experiments, where you manipulate some variables, and sometimes you just observe how players try to find a move. There was also a fair amount of computer modeling. And interestingly, this research also had strong links with AI. And if you want an overview of this research, you can find it in my recent book called The Psychology of Chess. In fact, in this book, I also talk about more recent research, so the current research, which very roughly goes from 2000 to now. Now, the old themes are still present in this new research. However, there is very clearly a shift in emphasis. And the new themes have been deliberate practice, individual differences, in particular the study of intelligence. Also, a lot of research has been done on education, in particular the question of transfer. I'm not going to say anything else about this today. And also there has been a lot of research about aging. And if you look at the methods, still experiments are used massively. However, questionnaires have been used. Researchers have been used questionnaires much more now than before. And also, what is really new is the use of databases to do research on chess, and that's what I'm going to focus on now. So first, I'm going to give you a brief summary of the methods that we used, and then I provide some overall statistics, and after I look at specific examples. So we were interested in publications that use the chess databases to answer psychological questions. Now, psychological questions was very broadly defined, but the point is that we excluded publications that focus only on machine learning, on computer science, including AI, and also publications that addressed only questions related to chess knowledge. So, for example, if a paper look at the endgame or a certain part of the endgame, queen pawn against queen, and decides that it's winning or not, that we didn't accept that as a psychological question. It's more of a chess-related question. So far our search has been informal, but I think we have got most of the publications, and in fact we have found 37 publications. So here we have the publications as a function of year. As is obvious, most of the publications are after 2000. And there were two exceptions. The first one in 1975 is the book by Elo on the Elo rating. And in that book, in addition to technical discussion, mathematical discussions about the Elo rating, Elo also discusses things like aging, which is obviously a psychological question. In the second paper before 2000 is a paper by Charnes and Gerczak, where they look at participation rates as a way to answer questions such as gender differences. But again, most of the publications were published after 2000. Now, if you look at the type of data used, most of the publications use the Elo ratings or similar ratings, like, well, typically it's the ratings from the International Chess Federation, but in some cases, the ratings, for example, for the German Federation were used. About 15 papers look at specific players' information, such as age or gender. About 10 papers look at game information, such as the number of moves, the outcome, and so on. About 10 papers look at the entire game, and these papers typically look at, well, analyze each move of the game. And these analyses were done using a computer program, such as Stockfish. Then some papers look at openings and try to make some decisions, for example, about risk using openings. And related to these, some papers looked only at the first move as a kind of very rough approximation of the kind of opening that was played. I'll give you an example of that a bit later. Now, if you look at the kind of topics that were discussed, most of them were about cognitive psychology. That would include things like learning, but first of all, decision making and problem solving. So where was the best move played, were there mistakes, and so on and so forth. About 15 papers look at social issues related to social psychology. And most of these papers were about gender differences. And finally, there were a few papers about biological psychology, for example, papers about aging. Now I'm going to discuss in some detail 4 examples of using databases, chess databases, to answer psychological questions. And the first one looked at the following question: did the Soviets cheat to beat Bobby Fischer? As you may remember, Tigran Petrosyan won the Curaçao candidate tournament in 1962. However, after the tournament, Fischer, who played in that tournament, accused the Soviet grandmasters of cheating. And Fischer made 3 points. Well, first, the Soviet grandmasters consulted together during games. He also argued that some of the games were actually fixed. And also he argued that they were rapidly drawing amongst themselves to conserve energy. And in a paper published in 2009, Mool and Nye addressed the third allegation, so the rapid draws, and they studied that in a statistical way. Of course, the point of making a draw very rapidly is that if you do that, you save energy, and then you have more energy when you play against non-Soviet players in that case. So they look at about 4,400 games from 1940 to 1964, and they compare 2 types of games. Basically, games in international tournaments and games where there were only Soviet players. And more specifically, they look at all FIDE events like interzonal tournaments or candidate tournaments, and they look at all the games in these events, excluding the games of playoffs. So a playoff would be if 2 players finish at the same level, but only one can be qualified, then there is a small match between the 2 players. So they excluded these games, but look at all the other games. And they compare that to the games played in the Soviet National Championships. And they got their data from the chess metrics, and then also got some data from the chess-based mega database. For example, data about the order of the games in the tournament or the number of moves. And here are the key results of their study. Well, first, they found that draws were more likely in FIDE events than in Soviet championships, which support their allegation that Soviet players would basically collude and make draws between themselves together. But the evidence so far is not very strong. Much stronger is the following evidence, which are about games played in FIDE events only. And here they found that 2 Soviet players playing together were much more likely to make a draw. They did that in 67% of the cases than games where at least 1 player was a non-Soviet. In that case, the percentage was 48%. So that's quite a large difference. And also, if you look at the number of moves, then you find that the draws between 2 Soviet players were actually shorter than the games where 1 player was not a Soviet player. And of course, if you play a rapid draw, as I said before, that's going to save energy, and you can use this energy in future games. And the authors tried to estimate statistically the value, basically, of avoiding such an effort of drawing rapidly. And they estimated that basically Soviet players, by drawing rapidly, on average, saved or gained about 68 ELO points. Mool and I also did some Monte Carlo simulations to estimate the effect of Soviet collusion in specific tournaments. And I'll talk only about the Curaçao tournament and the case of Fischer. And basically, they estimated that Fischer's probability of winning the tournament without collusion would be 0.19. However, with collusion, his probability of winning the tournament would go down to 0.03. Now, if you put all this data together, I think they make a very good case that Fischer's accusations were correct. The second example is about the seasonality of birth. And here the question is whether the month at which you were born is going to affect the likelihood that you're going to become a chess expert. And this is a study I carried out with Philippe Chassis. And in that study, we looked only at the players in the northern hemisphere, because of course the seasons vary as a function of the south and northern hemisphere. It's not really a big deal because most of the players come from the northern hemisphere anyway. And we look at the FIDE rating list, and specifically we look at the second list of 2005. And in that time, the rating list had information about the date of birth. I think you don't find this information anymore now because of data protection. But in that time, you could find this information. So obviously, we use that information to identify the month of birth. And we were interested in players having an ELO larger than 2000, which are basically experts. So that's all players who are candidate masters and above. Our sample was just above 42,000. And we did find that, in fact, there was a seasonality effect. More specifically, chess players tend to be born more often in the first half of the year than in the second half of the year. If you look at all the experts, about 52% were born in the first half and 47% were born in the second half. And if you look only at the grandmaster players at grandmaster levels, players in an ELO larger than 2,500, the difference is actually larger. About 57% of the grandmasters were born in the first half of the year against 43% in the second half of the year. Now, of course, you could claim that the study is not conclusive at all because that might just reflect the pattern in the population. So we need a control group which reflects what happened in the population. And it took us quite a while actually to find such a control group, but at the end we did find it. And basically we look at the EU population, so the population of the European Union. And of course, we selected only the chess players that came from an EU country. And in our case, we had about 25,000 players. And then we got the date of birth of the EU population from 1973 to 2001. And the sample was above 105 million individuals. So you cannot beat that as a control group, as the size of a control group. And again, we did find that the players were more likely to be born in the first half of the year. And here the percentages were 52% in the first half and 48% in the second half. What this really means is not totally obvious, and maybe we can talk about that in the discussion. But here we have the detailed results. On the x-axis, we have the months, the y-axis, the percentage of birth. In blue, the EU chess experts, and in pink, the EU population. And in green, we have the percentage difference. And you can see that for the month from January to April, the likelihood of being born in these months is higher for the chess players, and then you get the reverse for the remaining months. So the conclusion is that there is in fact a seasonality effect. My third example is the question of civilization differences in risk taking. And this is again an example study done with Philippe Chassis. So here we looked at the concept of civilization, which is a concept from political science. And this concept was developed by Huntington in 1996, where he defined a civilization as a group of states sharing similar values. And his point is that after the end of the Soviet bloc, the civilizations would not be defined mainly as using political values, but other values, including religious values. And here are the 11 civilizations identified by Huntington: the African, Buddhist, Ethiopian, Hindu, Japanese, Jewish, Latin, Muslim, Orthodox, Chinese, and Western. So our question is whether you can find differences between these civilizations with respect to risk. We defined risk as the standard deviation sigma around the expected value mu, which is a standard definition. And to validate our definition, we use the Fritz Big Database 2010, which has about 1.5 million games. And we were interested in the first move of the game. And we categorized the first move in 3 main groups. One, E4, which we called risky based on the chess literature. Then we had one D4, which we call conservative, and all the other moves, we call them mixed. And then we computed the standard deviation for all of these 3 moves, which are supported or labels risky, conservative, and mixed. So the standard deviation was 41.45 for E4, 40% for D4, and 40.6% for the other moves. The differences are not big. In fact, they are quite small. However, if you do a statistical test, the fact that there are risk differences between the 3 moves is very highly significant, just because of the huge number of observations. And then to go back to the question of civilizations, we look at all the games from expert players for 11 years, from 1999 to 2009. And our sample was about 670,000 games. And also, using the FIDE rating list, we were able to identify the country of most players. Also, we had the requirement that for each civilization, there should be at least 1,000 games. This is just for statistical power. This led us to exclude 2 civilizations, the Ethiopian and the Japanese civilizations, which didn't have enough games. So here are the results. On the x-axis, we have the civilizations. On the y-axis, we have the percentage of use of the 3 strategies, so 1E4, 1D4, and the other openings. And you can see that there are differences in the proportion of the different strategies. So in dark gray, we have the risky strategy, 1E4. D4 is in white, and the others are in gray, light gray. And for example, the Jewish civilization is not very risky, and it's much more conservative. And you get the opposite, for example, for the Buddhist civilization. And another way to look at risk is whether players are happy to finish the game very quickly with a draw. And again, we did find differences between the civilizations. The Buddhist civilization, well, confirms that it is very risky because there were no quick draws with the Buddhist players. However, the Orthodox players tended to have quick draws very often. Of course, the question is whether we can transfer that, so this data from chess to, for example, politics. Is it the case that the Orthodox civilization is kind of risk averse? Is it the case that, well, the Orthodox civilization would include Russia? Is it the case that Russia doesn't like to take risk at a political level, and that countries in the Buddhist civilization, for example, Thailand, on the contrary, is taking many risks? So that's obviously a big question. And we were very careful about the discussion of our paper. My final example is about aging, and this is a paper carried out research. They were interested in the hypothesis that age is kinder to the initially more able. And that's an hypothesis that was proposed by Bloom and Jarvik in 1974. So the idea is that if you are an expert in a domain, in a sense, you age better than if you are not an expert in a domain. And they used the German chess rating database, which had about 130,000 players. And they argued that the German database was preferable to the FIDE database. For example, all the tournaments in Germany are included in this database. And also all skill levels have been included for many years in that database. For example, the beginners are included, which wasn't the case with the FIDE rating database. And they got both sad news and good news for the experts. The sad news is that age is more cruel to the experts with respect to the initial decline. And the good news is that after the decline, the stabilization of this decline occurs quicker with the experts. And these results are displayed in this graph. So we have age here on the x-axis, the rating. The non-experts are in light gray and the experts are in dark gray. The open circles are about the maximum of the function. And you can see that the maximum of the function is quicker with the experts. So basically the decline starts earlier, which is the point made here. And the black circle is about the stabilization of the decline. By the way, the maximum is the first derivative of the function, and the dark circle is about the second derivative of the function. So after the decline, the slope is going to get milder after this point. And this point of stabilization occurs earlier with the experts than with the non-experts. Their paper had many more data or results, but I just focus on the key result. Now, what are the strengths of using chess databases? Well, first, the samples are very large, which is quite useful. Also, the entire world is covered, which basically avoids you biases linked to specific cultures. And this is a big problem in the psychology. Most research in psychology is basically looking at white Anglo-Saxon individuals. And it's not very clear whether you can generalize the results in typical psychology experiments to other countries or cultures. With chess, because we look at the entire world, basically we don't have this problem at all. Also, because we look at the entire world, the players are going to speak a multitude of languages. So in fact, we control for different types of languages, which is very interesting as well. Many of the data can be used chronologically. So we can, for example, look at the development of expertise as a function of age, which is what Vacci and colleagues did. And also, there's different types of information. So it's not only about rating or the quality of moves, but you have different things. And with a bit of imagination, you can actually come up with interesting studies. However, there are also some weaknesses in using chess databases. Well, the main one, I think, is that we are talking about a self-selected population. So it's not clear whether the chess players are representative of the general population. For example, it's known that on average, chess players are more intelligent than non-chess players. So that's obviously a big limitation. Also, in some cases, the databases might suffer from inherent biases. So for example, with the ILO-FIDE rating list, there is an inflation of ratings over time. And it's not very clear how you can control for that. Also, in some cases, the selection of tournaments is a bit arbitrary. which is why Bachi and colleagues use the German database rather than the FIDE waiting list. Also, in some cases, the databases might not contain the right type of information for the kind of research you want to do. So, for example, if you are interested in deliberate practice, I don't think you can use chess databases to study this question. Well, some people have done that, in fact, and they have used the number of games played as a proxy for practice, particular deliberate practice. But I think this is just not correct. The number of games you played is not really the same thing as a practice. Now, to summarize, well, first, I've argued that a huge amount of research has been carried out on chess. And also, I've argued that the research interests and methods have changed since roughly 2000. And in particular, databases have been used much more often nowadays than before. Then I've illustrated the use of databases with different approaches. I've talked about the probability of winning, the month of birth, the first move of the game, and also the elo rating. Of course, other measures can be used. I think in general, the databases have led to interesting results, sometimes very intriguing results. I would say the interpretation of the results is not always that easy. And also, I think you have to be careful that chess databases cannot answer all questions. They are very good to answer some questions, but not all of them. And finally, I think over the years, chess has been a very active domain of research, and it's very much the case currently. And in general, I would argue that the future of chess research is bright. Thank you very much. Questions?
There's quite a few questions that came in through the chat, and one was about handedness, left-handedness, and chess skills. You know something about the correlation?
Yes, I carried out a study about handedness a few years ago with Guillermo Campitelli. And what we found is that if you compare chess players against non-chess players, chess players tend to be more often non-right-handed. So if you put left-handed and mixed-handedness together, chess players basically are more often left-handed and mixed-handed. So if I remember correctly, the prevalence of right-handedness or non-right-handedness in the population is about 12%, and with the chess players, the prevalence was 18%. So it's not a massive difference, but there is a difference. However, if you look at the correlation, if you correlate handedness with skill in chess, there is no correlation at all. So basically, the difference is between players and non-chess players, but nothing within chess players.
You presented these data on the draws in different cultures, and was this controlled for the playing strength and for the type of tournaments? I mean, a high rate of short draws. It's typical of round robin tournaments where players are in that have no interest, but they are just there because they get a little bit of money. But some others are fighting for norms, for instance. Or it can also happen in team competitions in the end of the season quite a lot, because the teams are not playing for anything anymore. Was this controlled for?
No, we didn't control for that. But in fact, there are probably many things we didn't control for. For example, you could argue that different countries have different ways of teaching chess or training experts. And maybe if your best grandmaster plays e4, everybody in the country plays e4. Well, what we argued is that well, things like what you play at the beginning and the end of the tournament, this is going to cancel each other out, given the large number of games. We did argue that basically the the tendency to take risk is a function of the value of a given civilization. So we made the point, which is a bit risky point, I agree, that basically from our data about chess, you could make, well, you can make conclusions about what happens in politics. I'm not sure I would buy that now, but that's what we argued in the paper.
There was a big debate about the birthday, but I think most of the data here that are interesting are not from chess. They are in different fields of sports, isn't it?
Yeah, I think that's really the strength of our study. Thank you for asking this question. So this seasonality of birth has been found in many sports. For example, hockey is very strong in hockey, I think football, but other sports as well. You find that also in education in general. So in some countries, for example, children born between September and let's say December do better in school than children born in other months in each country. And the explanation here is that, well, basically, if you are very young and you compete against players who are older, your chances are not very high. So if you play football, for example, and you are 11 months younger than your friends, basically they are going to be quicker, they are going to be stronger, and you have no chance at all. And coaches basically are going to say, oh, look at this guy, he's quick, he's strong, so he must be very talented, and he's going to be selected. And the player who is younger, because he's a bit slower and less strong, he's not going to be selected. And then you get a kind of self-reinforcing effect. And the same, probably, yeah, I would say the same happens in all sports, and possibly even in education. So if a teacher notices that a child is very good in mathematics, they are going to reinforce this child, maybe in an indirect and implicit way. And this child might be good in mathematics just because she's a bit older. Now, the beauty of the chess study that we don't have this problem, because first we took players in all the world, and different countries are going to have different regulations. And basically, some age groups that would be favored in some countries are not going to be favored in other countries. So everything is going to cancel each other. But also, and maybe more importantly, in chess, children don't play only against children of their age, but they can play against children, older children, and even adults. So I think our seasonality effect is much harder to explain than in other sports, where the explanation is rather straightforward, I would say.
David Smurden and David Kramelli want to follow up on the first move preference. David Smurden, can you go first?
Yep. Hi, Fernand. Every time I try to just write a question in the chat, Stefan somehow manages to rope me into interactive participation. I just wanted to ask about the first move measure, because it's been used in a few papers since your paper. Andrea had a publication in Journal of Economic Behavior and Organization where they also use this, looking at gender differences. And I've always been a little bit skeptical about this particular measure. My main concern is just about the selection effect, that when people start out playing, they're more likely to play 1e4, so you get more beginners playing 1e4, but we know that they have more decisive games. I just wanted to know whether you checked for that. And related to that, now that we have all these papers using within-game measures with computer evaluations and so forth, it is possible to get more precise, I guess, proxies for risk. So just wondering what you think about those.
Yeah, I agree. Well, it's a very rough measure, no doubt about that. Also, I agree with your point that if you use computer evaluations and make some assumptions, you can have a much better measure of risk. But it's much harder to do, much more time-consuming. Now, we did validate our assumption that E4 was more risky by looking at the standard deviation. So I think the measure is valid. Again, the differences are very small. So Maybe that's, well, obviously it's a bit of a limit of the study. I think one study in a Journal of Economics look at a much more way of defining openings. So they did not look only at the first move, but they look at variations. I think it's a better way to do it, but it's obviously much harder, and you have to make many assumptions. And also, even whatever opening you play, you can play it in a risky way or not risky way. Even if you play the Caro-Can, which is supposed to be a boring opening, some players like Kasparov played it in a very risky way. So, well, I think you can use the opening as a proxy for risk, but it's a very rough approximation.
If there are no immediate questions to Fernand, we can go to our next presenter and see if there's time left in the end. We can probably still come back to some of the general questions about the applicability of chess data or some exchanges about options that are open for future research. So thank you, Fernand, and also to Andrea, who hasn't spoken, but for preparing this very interesting overview. And we have Dainis Zegners next, an economist. It's not so surprising maybe that there are many papers in psychology using chess data, but it may need some explanation why there are so many papers by economists. Also David Smerdon, who's spoken earlier here with his questions and comments, is a behavioral economist, and Dainis Zegners is an assistant professor at the Rotterdam School of Management, and he has been involved in 2 chess data related publications just recently out this year. I think, Dainis, your focus will be on one of the papers that you will discuss here. Please go ahead.
Yes, thanks a lot for the kind introduction, and yeah, very happy to present some of the work that we have been doing using chess engines in our research. Let me share my screen.
Looks good. It's on.
Yeah. Yeah, so in particular, the work that I'm going to present is work together with my co-authors, Anthony Strittmacher from NCR, who I think is also in the session, and Uwe Sunde at LMU Munich. And we have been involved actually in 2 projects. So one that has been recently published, that we're very happy about in the proceedings of the National Academy of Sciences. Then we actually have another working paper that we're currently working on. And later on, Christian will present another project that I've been involved in. So actually, it's by now, it's more than only 2 projects. In all of these projects, we use a chess engine. And why is it advantage? So what is the advantage of using a chess engine in research? So for one, you have, of course, the setting of chess, which is very interesting. And Fernand and the others gave a nice introduction why this is useful for looking into research. But explicitly, if you use chess databases, you have the advantage that you have professionals competing in high stakes settings. If you take tournaments where they compete for significant prize money, this is different than in other studies where you only have subjects in the lab, students that only have very low incentives to give their best. And using the chess engine, you have a clean measurement of performance that is relative to an objective benchmark. So it's not like ELO that is always like a relative measure of chess strength or your performance, but using a chess engine, you have this relative objective benchmark that you can also use to make comparisons across time and across different settings. And this has been done, of course, already by computer scientists. So we by no means the first to use this methodology. So Kenneth Reagan has lots of papers on that, and there's also other papers in psychology. There's also 1 or 2 papers that I'm aware of that use this methodology. And recently, it also has become used in economics. So there's like this gender difference paper by Bacchus et al. And I'm aware of a couple of like 5 to 10 other papers that are, as far as I know, mostly in the work in progress stage. So to use the chess engine research, in our research, we compute basically 3 measures. using the chess engine. Stockfish in our example, but of course you can also use other engines such as Komodo. So one, we compute for any given chess position in the data set, whether the human chess player played the best move according to the chess engine. So this is a binary measure, yes or no. Did the human play the move by the chess engine? And additionally, you can also look at the change in the engine evaluation after the player made a move, which then effectively gives you a measure of the size of the error in a pawn unit. So you have a numerical measure of how strong was the move that was played by the human compared to what the chess engine suggests. And additionally, we also compute another measure that's actually interesting to use. It's a measure of kind of a proxy of a complexity of position. So we calculate how long did it take the chess engine to reach a fixed search depth, and this is directly related to the branching factor of the chess tree, basically. So how many branches does the chess engine need to consider to reach a certain depth? And this is a measure, we take this as a measure or proxy of complexity of a given chess position, and you can compute this also for every position in a chess game and in your whole data set. Is this a good measure of playing strength? So just as a check, there's also others that have shown this, is that generally you find also that stronger players, they also have a higher probability to play the best move according to the engine. And also if you measure basically the quality of moves in terms of how much the evaluation of the chess engine changes after a move has been played, you also see a very strong correlation that the stronger the chess players, the higher the likelihood that the evaluation of the chess engine does not change after the player made a move. So we therefore have kind of this measure of objective strength of the chess players that we then can apply to settings. The one paper that got recently published, there we look at cognitive performance over the life cycle. So this is a longer stream of research. Fernand also, and also before that, mentioned that there has been already a couple of studies using this in the chess setting. But the basic question is, how does cognitive performance vary over an individual's life cycle? And what we can add to this literature is kind of how did this change over time? Because we can use the chess engine to evaluate the moves of the players. And generally, this is not an easy question to answer, because you need like a measures of cognitive performance. You can use something like IQ tests, but very often you have these measures only either like once for an individual, as in the case of IQ tests. You also need to have a measure that's comparable over long periods of time. So IQ tests, for instance, I think they have been started to be used like in the 70s, but you cannot go more back in time. And also you want to have some kind of task where you can disentangle performance changes from changes in technology and so on. And there, chess is a very nice setting because the rules of chess have essentially stayed the same. And also in terms of technology, there's new technology today in terms of chess preparation that you can do before coming to the board. But then the task sitting at the board is more or less the same today than it was 100 years ago. And we use this fact in the project so that we have like new data and methods measuring the age profile of cognitive performance and the dynamics over the last 120 years using the chess database. So I'm not going really into the literature, but we are economists, and this speaks to a literature in labor economics that is interested in the relationship between age and productivity. There's also related work that looks at how scientific creativity changes over individuals' life cycles. Then there was already mentioned this work in psychology on expert performance, mainly by Anders Ericsson and co-authors. There they're also interested in how long does it take experts to reach their performance peak. So Ericsson have found that typically it takes about 10 years of deliberate practice for experts to reach their peak, which then has been popularized by Malcolm Gladwell in the so-called 10,000 hour rule. And also, yeah, there's also papers using aging in chess, most famously in Arpad's ELO work on the ELO rating. There he also makes these computations of how does individuals' ELOs change over their life cycle. But here it's clear, because ELO is only a measure of relative strength, you cannot really make comparisons over time. So you cannot really compare Fischer to Morphy or Steinitz, because it's always only a relative measure, ELO. Yeah. And so what we do in this paper, so we use 25,000 chess games, including about 1.6 million moves played by all the world champions since Wilhelm Steinitz until Magnus Carlsen and their opponents. We have information on the age, birth year, and the year when a game was played. And we compute the performance, productivity during a game using the share of optimal moves of these players. And actually this data set is actually publicly available from Aleo, who has done other work on this data set. What do we find? So we find a general increase in the strength of the chess players over time. So you see that during all of this period, starting with Wilhelm Steinitz until Magnus Carlsen, there's general increase in the chess strength. So players get stronger over time. And then also interestingly, you see kind of what looks a little bit like an acceleration starting in the 2000s, which is roughly the same time when chess engines, of course, become sufficiently strong so that you could practice with them. Then the age profile that we find, it's also a little bit similar than these other studies. So we find generally kind of this hump shape, that there is a general peak between the ages and from 20 to 40, where there's like a slight peak at 35, but generally it's kind of like more hump shaped, that you have this plateau where you have your peak, and then after 40 we see generally decline in the share of optimal moves of a player. Now it's get interesting because we can make these comparisons over time, and okay, maybe for chess players not that surprising, but it's still very interesting to see that we see that this general increase in the chess strength when we start looking from older cohorts of players born in the last or 19th century, then comparing it to the recent years, we see this general increase, but we also see that this profile gets steeper. So meaning that today, the chess players, the world champions, they reach their peak already at the age of 20. They start to be very strong. And we find this also using more sophisticated empirical models. There we find also this general pattern, and I don't show it here, but what we also did is a question that we were interested in, because this is something that labor economists are interested in. Is it more the birth cohort when somebody is born, which determines this profile, or is it the actual time where somebody's playing in? There we also did find, if we look at the variation across time, we don't find such a strong pattern that the younger players are getting stronger. So we see this as evidence that it's mostly driven by the time when somebody is born and basically starts practicing and training for chess, whereas compared to when does somebody actually play chess. We have a more sophisticated empirical model in our paper where we try to rule out some things that might be driving these things. What we can rule out as main drivers is that fatigue, as measured by the length of games, is driving lots of this data. So we find that this is not a strong driver. We observe some changes in complexity of the chess positions, but they don't seem to be strongly correlated to the patterns that we find in terms of the profiles. And we also find that opening knowledge, it might explain a little bit of this acceleration in the 2000s, but also if you look at later stages in the game, we still find very similar patterns. So it doesn't seem to be a strong main driver of our results. What we find as possible explanations for especially this increase in younger ages, in our data, we see that players more recently born, that they have played more competitive games, so they have more games in the database. So it seems to be that at a certain age, they have already more experience playing at higher levels of chess than the players like 100 years ago did have. And then what we don't see in our data, but which is very clear that this explains to a large extent this pattern, is that, of course, today with better training methods, these days with chess engines and online even, and better access to knowledge and books and internet, people, of course, can train better and reach their peak earlier than it was able when you go more back in time. As a summary, so using chess engines as a benchmark to objectively measure cognitive performance, it opens up many interesting avenues for research. And actually, We think that this just like foreshadows similar possibilities in other settings, because chess is the one setting where already 20 years ago, the artificial intelligence, the chess engines become stronger than the humans, but you also see this now happening in other fields. So now like in Go, but now maybe chess, artificial intelligence is better in making some kind of medical assessments than experts. So we think that this type of methodology that we now see already with chess, we think that we will see much more in other settings using other artificial intelligence that is now also stronger than the humans. And what we can learn from chess and using the chess engines to examine cognitive performance over the long run, as we did in this paper that I presented. So we see this general steady increase in quality of elite chess. We see a general peak in performance between the ages 20 and 40, but we also see that the more recent cohorts, they reach their peak at much younger ages than previously. And yeah, this is it. Yeah, thanks a lot for the research, and I'm happy to answer questions or get in touch if you have additional questions or comments on our work.
A technical question came through. You say you analyze moves after move 10. Nowadays, opening theory gets more and more complex and long. Did you control for this and in the comparison? That,
yeah, so I think like in these main graphs that I showed there, we exclude the first 10 moves, but of course these days it goes beyond move 20 or 30. But in this particular paper, we have also robustness checks where we show that the general patterns, they remain the same. If we look at stages like after move 30, then we get very similar patterns. So maybe not this, I don't remember exactly, so maybe this kind of acceleration that we saw in the 2000s, that might be partly related to the opening knowledge, but this general pattern that players get stronger, this we also see in later stages of the game.
any immediate question to Dainis? We are a little bit short on time now. I see one you, did you try to use the outcome of the game after controlling for ELO difference as a dependent variable?
Yeah, so in this work, it's difficult to take ELOs because they're only available since the 70s. Okay, we could maybe take historical ELOs. So in this work, we didn't take ELOs into account, but in other work that we're doing where we have ELO numbers there, of course, we take ELO numbers also into account. Yeah.
Do you think it would be the same outcome, or do you see the in the other paper? Do you see the same outcome, or is there a?
We see actually it was kind of surprising. We didn't see such a strong impact of the ELO number of the opponent. So there seems to be a little bit of an effect, which of course anecdotally has to be true. But it's not really a big driver. And I've also spoken to other chess players. They also think that, at least like for elite chess players, okay, they might play a little bit weaker against weaker opponents, but it's not such a huge effect. So basically, we didn't find strong effects of this.
So thank you, Dainis. You kind of confirmed things that Fernand said about power of these data. And now on to your co-author in a paper I have written about on ChessBase and on ChessTech just last week, also advertising this conference to some degree. So our next speaker, your co-author, also an economist, is Christian Seel. And chess players, especially from the German language area, are familiar with the name. Christian is also a very strong player, a strong IEM, playing in Bundesliga on first board. And there, I think he may share in his presentation that there was a little bit of an influence. This idea is coming from his playing practice. Christian, please, you're on. Christian is at University of Maastricht, also in Holland, and you see another co-author also in Holland. But I think none of you is Dutch. Dainis, you're also German?
Yes, I'm actually Latvian by heritage, but born in Germany. Yeah.
Okay, Christian.
Yeah, thanks a lot. So this is joint work with Stefan Kühn and Dainis, and basically both Stefan and Dainis worked on chess-related questions before. I'm more of an economic theorist, so I would not see myself mainly as an academic on the paper, but more as the chess player on the paper. So yeah, the question, though, was a question that basically I had when I was playing chess online, and I was just confused. How can you play so poorly? Right, my feeling was if I play like 5+0 blitz live, I'm doing just so much better, and I see just so much more compared to when I play online. So I was thinking, well, is this something which just happens to me? Is this something because maybe it's just not incentivized to play online usually, or is this something which holds true more generally, that the quality of play is just much worse when you play online versus live? So I had the idea for the project mainly when I saw that for the first time we had a really high stakes chess tournament taking place online, which was the Magnus Carlsen Invitational. So yeah, that was basically the idea, to have this tournament, Magnus Carlsen Invitational, versus data which we had from previous tournaments. So in particular, we compared the quality of chess moves in the Magnus Carlsen Invitational to the quality of chess moves played in the World Rapid Championship. So we took here for the World Rapid Championship the years 2015 till 2019. And for the Magnus Carlsen Invitational, we just took the quality of play there. So we wanted to make sure that the conditions are otherwise comparable, so that the only difference is really whether you play online or whether you play in a tournament hall. And therefore we chose tournaments which had the same time control. So in all cases, the time control was 15 minutes per game, plus a 10-second per move increment after you made your move. So it's also nice to look at data from Rapid rather than data from Blitz, because in Blitz you might argue that there might be a time difference between entering a move and physically making a move. So when you play like a 1-minute game, for instance, it's clear that it's quite different to do this online versus live. However, if you think about a Rapid game, 15 plus 10, so it's around 25 minutes, then we think that, yeah, there is not really such a huge difference between the two settings. Yeah? So we don't think that this really influences the results. Then, and because we are economists, we need things which are incentivized, because otherwise our colleagues do not trust us. So we wanted to have prize funds which are kind of comparable between the settings, and therefore we were quite happy to find this Magnus Carlsen Invitational, where the first prize was quite high, and I think in total they had 150,000 euros in prizes to be shared among the 8 players of the tournament. Then we also wanted to compare the quality of play within each player. So we had 7 players who competed in both formats. So, and these were really like the top players of the world, including Magnus Carlsen, Hikaru Nakamura, Jan Nepomniachtchi, and these kind of players. So we basically, for each of them, then compared the quality of the moves using the kind of technology that Dainis already alluded to, and that both Dainis and Stefan had used before. So basically, I just hopped on the ship and just gave them the idea, and then they did all of this interesting analysis on the data. So the empirical approach was to analyze the quality of the moves with the help of Stockfish at a depth of 25 ply. Dainis had a computer on which he could run this quite efficiently. And basically the main specification, which we are estimating, uses an exclusion of the first 15 moves of the game, but we also have robustness to check for 10 or 20 moves. And I will say a few words about this at the end. We controlled for quite a few things, such as the complexity of the position. I think Dainis mentioned this measure before. The remaining time on the clock, your ELO and the ELO of your opponent, the pawn metric before the position. So for instance, maybe you make bigger mistakes when the position is already +6 than when the position is equal, just because when the position is +6, it's quite clear that you are going to win anyhow. So maybe if you make a small mistake, it's not really a big problem. and the number of games on the same day to account for fatigue of the player. Yeah, the method was taken basically from Dainis and Stefan's previous research. So that's basically their empirical approach, and we just entered it for these tournaments. So what we find is that players have a significant increase in the error size when they are playing online. And this result is very robust, even if we exclude more opening moves or fewer opening moves, even if we exclude positions, for instance, with an advantage above 2 for one side. And in all of these cases, we find a significant increase in the error size when players play online. Well, we asked ourselves, what is the reason for that? I mean, I was just experiencing it on my own as well. So I also thought about it before. We cannot really say that much within the current empirical approach, but we have 3 potential explanations. One is the lack of peer pressure. So you do not sit across your rival, but you, in the best case, have him somewhere on the screen. But this, of course, does not feel the same as if you're experiencing somebody who's really focused and maybe a bunch of other players who are really focused very close to you. The second explanation is quite close to that one. It's the lack of a tournament atmosphere. So you don't go to a tournament hall, but you're sitting at home. In the best case, maybe you come just from the bathroom and you just enter your room in which you are playing. So maybe this is less of a tournament atmosphere than what you would have at a real playing hall. As a related anecdote, Peter Heine Nielsen stated that Carlsen moved to a different location to play for one of the later tournaments to create a bit of this tournament atmosphere. So something like this seems to have been going on indeed. And finally, of course, it's a slightly different task because when you're watching the computer screen, this is basically a 2D task, whereas when you play when you move the wooden pieces, it's a 3D task. So it could also well be that this drives part of the results. Yeah, since we also want to publish it in an econ journal, we also talk about in how far this goes. Lets us draw conclusions beyond chess. And we argue that chess requires similar skills as other cognitive tasks. And maybe this paper could be seen as a first indicator that a home office in general might have some detrimental effects on such cognitive tasks. But we should be very careful here. I think that's what also the other speakers have already emphasized, not to overpush these policy conclusions. Other research has shown that whether you perform better or worse in the home office depends on the task. So for instance, there is a famous paper in which, by Bloom and co-authors, in which they test for call center employees, and they find that when call center employees are moved to the home office, they can even be as productive or even more productive. And one potential reason might be that there's just way less noise when you're at home compared to a huge call center. So we just see this as one piece in a very complicated equation when you decide as an employer between sending people to the home office or keeping them in the regular office, next to things like the cost of office space, commuting costs, the fact that maybe it's harder to build a team in this way with home office, and also maybe mental well-being in the long run could deteriorate in case people are just working from home all the time. So as I'm an economic theorist, I don't have any fancy pictures in here, but feel free to ask me anything, and hopefully I can give some answers.
Thank you. Did I miss a question in the chat? Please unmute your mic and shoot out.
Very random. I'm going to ask Christian if he could give me a virtual autograph for one of his first books, please, which I still use and value on the Philidor. Entirely unrelated to the presentation, but appreciative nonetheless.
Sure, yeah.
Thank you.
Hi, can I ask?
Sure, go in.
Hi, Christian. Thank you for the great talk. I wanted to suggest that I think it's very hard to differentiate between the effects of COVID-19 itself and the difference between, playing at work and playing face-to-face. And I wonder if you can get some data on face-to-face games before and after COVID-19, like sort of as a control group, like this in this method or something in that area. Have you tried that?
We could surely try that. I mean, right now there should be also data available, for instance, from this tournament in Norway, I guess, right? Which was played during the pandemic. So my personal guess is that the pandemic itself should not have had a huge effect. And this is basically because the different countries from which the players came, they were at very different phases of the pandemic, some barely affected at that point, whereas others were affected a bit more strongly. And all of these players made more mistakes playing online compared to playing live. So it's really quite robust in that sense. But I agree with you that this is one potential confound here.
Thank you.
Players are probably need to get used to the situation maybe in a year from now. And as chess is becoming more of an e-sport, maybe there's no difference anymore. What do you think about that?
I mean, I think players are quite familiar with playing online, right? But not for high stakes. And I think many players are also not familiar with playing for like a rapid game online, which is quite different from playing a usual blitz game online. So I think it's possible that quality will improve a little bit, but I don't think that it will reach the level that you get in live play. So at least that would be my strong belief that this is not going to happen. And if you see players like Nakamura, for instance, who is like playing online all the time, if he makes more mistakes online than live, then I would guess that that not all of the difference will be gone. So maybe I can say that Nakamura was the person whose error rate increased the least by playing online. So I mean, that was kind of what one would expect, that he would not feel as uncomfortable in this online setting than, for instance, Ding Liren or somebody, where maybe what you are saying is more true, that he played far less online before and maybe has to be has to.
Mm-hmm. Any other comments? Any other things that can be studied with this kind of data?
Just one observation. It's such a fascinating topic, this one, and I'm heartened that Christian has had similar thoughts but taken it further into formal study. Playing in the 4NCL this year, anecdotally, some teammates of mine noticed this, and actually one of them went as far as having a physical board with him and playing out the moves on the board as well as online to try and mitigate. But it also reminds me of the observation or the received wisdom that many trainers used to make, that you have to use over the board and pieces when you're learning. And I think that's starting to be debunked a little bit as we see a generation of players come through whose development through chess actually has been far more online based than over the board based. So I think there's a fertile area for a lot more study, and it's a really interesting one.
Can we take this as the final word? Because I think it wraps it up nicely, Sanjay. And yes, thanks everyone. Thanks to the speakers and to the participants. There's an exciting next session starting in just 2 minutes. You may rush on because that's also about science based on chess data. Although these questions about the gender gap relate directly to how the chess world looks like and to chess policy things, the gender gap, and David Smurden is one of the discussants. Thanks everyone.